Two strings support the 10 Newton object. The tension in string 1 is. So we are going to define the tension in string 1. And this is not moved, so this means this object is equilibrium. And this means some total force is 0. So the force equal so this is 10 Newton and this is exactly same degrees, so we can find that this can support about 5 Newton and this can support 5 Newton, about 5 Newton. So, and the force to the y direction gonna be 10 Newton. So the answer is gonna be this. A 2 kg mass lies on a horizontal rough surface, while a 1 kg mass hangs vertically. The string between them is massless, and the pulley is both massless and frictionless. One maximum coefficient of friction will keep the blocks at rest. So we can find the force, and this is gonna be force of gravity. And this is going to be tension force, and this is going to be tension force also, but this has the opposite direction, this plus and this is minus. And there is going to be force of friction. So this object is lying on the surface, and this is mean friction is strong enough to keep the system at rest. So the total force is gonna be 0, and this means force of gravity minus force of friction, and this is gonna be this. So the coefficient of friction is gonna be 0.5. A 5 kg mass is moving in uniform circular motion with a radius of 1 meter and a frequency of 3 Hz. Determine the tangential velocity of the mass. Determine the center acceleration of the mass. So we are going to find this notation. Tangential velocity is in the direction of motion and is tangent to the curving motion. And centripetal acceleration is directed toward the center of a circular path. So the velocity is gonna be this, and this is gonna be this. So 6 pi meter per second is gonna be the answer of the first question. And the tangential, the central acceleration is gonna be this. And we are going to apply this. So the second answer is gonna be 36 pi square meter per second. A circular child is sitting 2 meters from the center of a merry-go-round. The coefficient of friction and kinetic friction between the child and the surface of the merry-go-round are 0.5, 0.8 and 0.6 respectively. Determine the maximum speed of the merry-go-round before the child begins to sleep. And the coefficient of static friction is gonna be 0.8. This is gonna be 0.6. So what is the maximum velocity? So we are going to find this. For finding maximum velocity before to sleep, we are going to find this equation for finding maximum velocity before to sleep. And so we can find the 4 meter per second. A roller coaster needs to complete a vertical loop that has a radius of 10 meters. What must its minimum speed be at the top of the loop? So the radius is 10 meters. To solve for the maximum speed, the minimum speed. To solve for the minimum speed, centripetal force must be as small as possible. The force of gravity cannot change. However, the normal force can be reduced to 0. So the normal force is gonna be 0. And it means So the answer gonna be 10 meter per second. A 1,000 kilogram satellite completes a uniform circular orbit of radius 8.10 8 times 10 times 6 meter as measured from the center of the Earth. The mass of Earth is approximately 6 times 10 times 24 kilogram, and the universal gravity constant is approximately 7 times 10 times 11. So determine the work done by gravity as the satellite completes one full orbital around Earth. So we can find this by using two methods. First is finding this by using the work, and the second is find this by using this gravity potential energy. So first, about force and displacement method. In uniform circular motion, such as circular orbitals, force and displacement are perpendicular. Perpendicular forces do no work, so work gonna be 0. By using this energy and work method, the work of gravity requires a change in height. In a uniform circular orbit, the height of our Earth's surface is constant, so work is gonna be 0. The force displacement graph depicts the force applied to a 2 kilogram mass as it's displaced 10 meter. The initial speed of the mass is 5 meter per second. The final speed of the mass is most nearly so work is equal to this, and this is gonna be the area of this graph. So the triangle's area is going to be found by multiplying 1 over 2 and h height and base. So final velocity is going to be 10 meter per second. The diagram depicts a 3-Newton block sliding down a frictionless 30 incline. The mass is initially at rest, the top of the incline. The work done by gravity is the final speed of the mass when it reaches the bottom of the incline is most nearly. First, the work done by gravity depends on only the object change in height. So the work gonna be gravity potential energy So the answer is gonna be 15 joules. And second, the kinetic energy of initial so we are going to apply these equations so we can find these. So we can find 10 meters per second. A rock of mass 5 kilograms is on a 10-meter tall ridge. If the rock is pushed off the ridge, what is the kinetic energy of the rock when it reaches the halfway point its descent? So this is gonna be the equation we are going to use. So final kinetic energy is gonna be 250 joules. The first version's time graph, the first acting to start 1,500 kilogram car during an accident. Determine the initial speed of the car. So mass is 1,500 kilometer. So the answer is gonna be 20 meters per second.